WebGPU gives you great power, but with great power comes great responsibility and a lot of potential bugs. While it's extremely powerful, it's very low level and verbose. Take a look at this example. We have a pretty simple particle system for WebGPU standards. It renders 500 particles using a vertex fragment shader pair. But what if we wanted to add a new feature? Let's say that we want the particles to have a more elliptical shape instead of just a circle. Well, we would probably start with the shader, change the struct to have 2 values for the shape instead of 1. Great! But now we also have to update the buffer. So we adjust its size after recalculating it. And we also need to change the initial data to match the new structure. Well, that doesn't look like an ellipse. What happened here? It turns out that changing from a scalar value to a vector changes how the data is laid out in memory. So we actually introduced a bug in the new write logic. Now it works. Since there was no error, we could have been chasing that bug for quite some time. What if we use TypeGPU instead? The code looks structurally similar, but we start with around 50 fewer lines of code, so finding what we need is easier. Instead of starting with the shader, we update the schema that defines the buffer layout. Since the shader and the buffer share the same schema, there is no need to update them separately. They adjust automatically, respecting the new memory layout. The only thing we need to change is the initial data, and since it's typed, we get an error immediately after changing the schema, so we just fix it. Data serialization is handled by TypeGPU, so there is no need to think about bytes. For more content like this, follow Software Mansion.